So, children, I taught about particulate pollutants. Now, what are the techniques followed to reduce the particulate pollutants? So, the particulates from air can be removed by using number one, electrostatic precipitators, number two, gravity settling chambers, number three, bed scrubbers or by cyclone collectors. These techniques are based on washing away or settling of the particulates. Here already I taught that micron, the particulate pollutants bigger than 5 microns. Already I taught it is entering the nasal passage. Micron means that value is 0.001 mm, 1 micron. Such a minute particle, minute living organism. Then regarding the black lung disease, I have sent a video that also can watch. Next topic what we are going to learn is about smog. What is meant by smog? Smog is a combination of smoke and fog. Smoke and fog, that is called smog. So it is a chemical mixture of gases that forms a brownish yellow haze over urban cities. Smoke mainly consists of ground level ozone, oxides of nitrogen, volatile organic compounds. Volatile means easily evaporating. Sulfur dioxide, acidic aerosols, gases, and particulate matter. So there are two types of smog. One is classical smog, the other one is photochemical smog. Photochemical smog. Classical smog, photochemical smog. Classical smog caused by coal, smoke, and fog. Photochemical smog is caused by photochemical oxidants. Now we are going to discuss in detail. Number one, what is classical smog, or other name is London smog, because it was first observed in London in December 1952. So it is called as London smog. It consists of coal, smoke, and fog. It occurs in cool, humid climate. This atmospheric fog found in many large cities. The chemical composition is the mixture of SO2, sulfur dioxide, sulfur trioxide, and humidity. These are all present. It generally occurs in the morning and becomes worse when the sun rises. And this is mainly due to the induced oxidation of SO2 to SO3, which react with water. First SO2 converted to SO3, then SO3 on reacting with water forming sulfuric acid aerosol. Chemically, it is reducing in nature because of high concentration of SO2, and so it is called as reducing smog, this smog. So here two questions: why classical smog called as London smog, and why it is called as reducing smog? Both you have to learn. So the effects of classical smog. Smog is primarily responsible for acid rain. Number one, acid rain. Number two, it causes poor visibility and it affects air and road transport. Then it also causes bronchial irritations. Bronchial irritations. So these are about classical smog or London smog or reducing smog. Now the next one is photochemical smog or Los Angeles smog. Los Angeles smog means because first it is observed in Los Angeles only in 1950. It occurs in warm, dry and sunny climate. This type of smog is formed by the combination of smoke, dust and fog with air pollutants like oxides of nitrogen and hydrocarbons in the presence of sunlight. So when the sun shines, it becomes worse in the afternoon. Chemically, it is oxidizing in nature because of high concentration of oxidizing agents like NO2 and O3. So it is also called as oxidizing smog. So many differences between both the smog. Classical smog is called as reducing smog. This one is called as oxidizing smog because it is having high concentration of NO2 and O3. There we have learned SO2 and O3. So it is also called as oxidizing smog. So as a put a tabular column, children, and they differentiate the both. Here classical smog, then here photochemical smog. You write and write the differences. At least write 5 differences and you can learn. So the photochemical smog is formed through the sequence of the following reactions. So nitrogen combining with oxygen forming NO. NO means nitric oxide. This NO once more combining with oxygen forming nitrogen dioxide. Nitrogen dioxide. This nitrogen dioxide in the presence of sunlight dissociate giving nitric oxide and nascent oxygen. Then this nascent oxygen with O2 forming O3, ozone. This ozone treated with NO forming NO2 plus O2. This NO2 once more in the presence of sunlight forming NO and O. Here this NO and O3, they are strong oxidizing agent and they can react with unburned hydrocarbons in polluted air to form formaldehyde, acrolein and PAN. PAN means peroxyacetyl nitrate. So what are the effects of the photochemical smog? The 3 main components of photochemical smog are nitrogen oxide, ozone and oxidized hydrocarbon. Like from hydrocarbon means compounds containing only carbon, hydrogen and oxygen. So hydrocarbon like formaldehyde, acrolein, peroxyacetyl nitrate is PAN, peroxyacetyl nitrate. So the photochemical smog that causes irritation to eyes, skin, lungs, increases the chance of asthma. So high concentration of ozone and NO can cause nose and throat irritation, chest pain, uncomfortable in breathing, etc. So PAN, peroxyacetyl nitrate. This is toxic to plants, attacks younger leaves and cause bronzing and glazing of their surfaces. Then it causes corrosion of metal stones, building materials and painted surfaces. So how can we control this photochemical smog? This can be suppressed by preventing the release of nitrogen oxides and hydrocarbons into the atmosphere from the motor vehicles by using catalytic converters in engines. Similarly, plantation of certain trees like pinus, pyrus, curus, vitis, juniperus, these trees, if you are planting, it can control the photochemical smog. If it is possible, means we can do, but the measures, controlled measures given. One thing from the motor vehicles only, all the hydrocarbons released into the atmosphere. So it should be controlled by using catalytic converters in engines. Next, in the plantation of some certain trees. If it is possible, the both, then the photochemical smog can be controlled. It is clearly given in page number 267 and 268. You can go through and mark, and these reactions compulsory you have to learn. What is the effect of the photochemical smog? What are the reaction taking place in the atmosphere? This should be learned.